Okay, we're going to be looking at this function here, f of x, which is also a piecewise function, much like the previous problem, except we've only got two separate pieces to this function, where we have negative 2x plus 3 is x is less than 1, and x squared where x is greater than or equal to 1, and we want to find if this piecewise function is discontinuous, or continuous I should say, and really at 1 is where we're really concerned about. We know that this is a polynomial function here, and I may have stated earlier that polynomial functions are continuous everywhere, or I should say everywhere continuous, and x squared, which is a polynomial function, and it's continuous everywhere also. So let's look at the math. Okay, so here's the setup, and first thing we're going to check is it looks like I'm checking f of 1 this time. Now I've been doing the limit first. Now remember, I think I said in one of the first tutorials on the continuity at a point, it doesn't matter which one you do first here, but it looks like I do f of 1. And f of 1, we're going to be using the x squared, because this says that x is greater than or equal to 1, where up here it says x is less than 1, which means you can't use 1 plugging into this function because its domain is less than. However, this says x is greater than or equal to, and the equal to part means that we're going to be using 1. So we can take 1, plug it directly in, and 1 squared is just 1. So that exists, and that's good so far. Now we're going to go ahead and take the limit of f of x as x approaches 1. Now we're going to be doing the left-hand limit first, coming in from the left side. That's the reason there's a little negative sign here, and well, we're just doing the direct substitution, plugging 1 directly in, and we get 1 out. So good so far. And then we do the right-hand limit, just do the plug the 1 directly in, and we get 1 squared, and so we get 1. Alright, so that means that the limit of the function f of x as x approaches 1 is equal to 1, right, because both of these are the same number. So I've got it written out here. Now, since f of 1 is equal to the limit of f of x as x approaches 1, therefore we can say that f of x is continuous, and I went ahead and labeled the actual point on the graph this time. I've just been labeling that x is equal to 1, but I just went ahead and labeled the point here. Alright, let's take a look at the graph. You can kind of see it down here. So here's 1 on the x-axis, and 1 here. And so this looks like the point right here, 1, 1. So this was the first part of our piecewise function, and then this here was the second part to the piecewise function. And therefore it's continuous at x equals 1.